Hello everyone. Today's 5 questions. First question is light of wavelength 6000 angstrom in air enters a medium of refractive index 1.5. What will be the frequency in the medium? So here we have to use the concept that the frequency during refraction would remain constant. It will not change. So you have to simply find the frequency of light in air only. The same frequency would be in another medium also. So using the formula nu lambda is equal to c, we can find out the frequency. Here lambda is given as 6000 angstrom. So frequency would be c over lambda, that is 3 into 10 raised to power 8 over 6000 angstrom 10 raised to power minus 10. So this can be written as 3 into 10 raised to power 8 over 6 into 10 raised to power minus 7, and this would be 1 by 2 or 0.5 into 10 raised to power 15 or 5 into 10 raised to power 14 hertz. So this is the frequency of light in the air, and it would remain same in the second medium also during refraction. It is not going to change. So option B is correct answer. And second question is, how does the frequency of beam of ultraviolet light change when it goes from air to glass? So here answer is also same, that same concept we have to use, that frequency does not change in refraction. When ray of light goes from one medium to another medium, frequency would remain same. So option A is correct for question number 2. Now coming to question number 3. Two monochromatic rays of light are incident normally on the face AB of an isosceles right-angled prism ABC. The refractive indices of the glass prism for the two rays 1 and 2 are respectively 1.35 and 1.45. Trace the path of these rays entering through the prism. Now you have to trace the path of the rays. Question number 3. Now you see this prism is right angled isosceles, means these two rays, these two sides of the prism are same. So if this is right angled, so this is 90 degree, and these two angles, they have to be same, 45 each. So this would help us to write here the angle of incidence, as this ray is falling normally on this face, so this would go inside the prism without any deviation. Similarly, another ray would also move inside the prism without any deviation, as it is falling normally. And here you have to draw the normal in order to write the angle of incidence. So this angle of incidence would be 45, and here also it is 45 degree. So for both of the rays, angle of incidence is 45 degree. Now, as we have to trace the path of the rays, so we have to check whether the ray is going to suffer total internal reflection or not. If it is suffering total internal reflection, then the ray would come back in the same medium. Otherwise, a refraction would take place. It means it would come out of this particular prism. So let us find out the relation, or we can find out the angle of incidence, whether it is greater than the critical angle or not. But we are not given the critical angle. Here we are given the refractive indices. But we know the relation between critical angle and refractive indices. So critical angle for ray number 1, this is 1 and this is 2. Critical angle for ray number 1 and ray number 2, this we need to find out. So instead of finding the critical angle, we can make simple comparison between the angle of incidence and critical angle using this method I am going to use here. So refractive index for ray number 1 and ray number 2 is given as, this is given as 1.35 and this is given as 1.45. So if refractive index is given, I can write refractive index mu is 1 over sine C. So I can write 1 over sine C1 is 1.35 and 1 over sine C2 is 1.45. Now, instead of using the trigonometric table, I can use simple trick. Here I can make the comparison of 1 over sine C1 and 1 over sine 45. Because here angle of incidence is given, because we have to just make comparison between angle of incidence and critical angle. So sine 45 is what? For both of the rays, angle of incidence is 45. So sine 45 I'm finding to just make comparison. Sine 45 is 1 by root 2 and 1 over sine 45 would be under root 2 and under root 2 is 1.41. Now you can easily make the comparison. Here this value is less than this and this 1.45 is greater than 1.42. So from these relations, first ray 1 and ray 2. Let's write down for ray 1, refractive index is 1.35, which is less than 1.41. Angle of incidence and angle of this critical angle we are going to compare. 1.35 is what? This is 1 over sine C1. So I'm writing this as 1 over sine C1 and this is less than 1 over sine 45. So you can write sine C1 reciprocating is greater than sine 45 or C1 is greater than 45 and 45 is the angle of incidence. So C1 here is greater than angle of incidence, or in other words I can say angle of incidence here is less than C1. But TIR would take place if angle of incidence is greater than C1. So for ray number 1, angle of incidence is less than its critical angle. So what would happen? TIR will not take place, but the ray would, as this is a denser medium, this is a rarer medium, so simple refraction we have to show here. So instead of going straight, it would bend away from the normal. So this would be the path of the refracted ray. So here you have to show deviation away from the normal. So this is the path of the ray number 1. Now for ray number 2, similarly we can find for ray number 2 the comparison between I and C2. For ray number 2, the refractive index is 1.45, which is greater than 1.41. Now 1.45 is what? This is 1 over sine C2 and this is 1 over sine 45. 45 is the angle of incidence for ray number 2 also. Taking the reciprocal, sine C2 is less than sine 45 or C2 is less than 45. 45 is angle of incidence, C2 is less than angle of incidence, or angle of incidence is greater than C2. So here angle of incidence has become greater than critical angle. So ray number 2 will suffer total internal reflection. So in this way, if this is 45, angle of reflection will also be 45. So this is the path of the ray number 2. So here you have to write also ray number 2 and 1, ray number as angle of incidence here is less than C1 or critical angle. So simple refraction would take place. Simple refraction, and here angle of incidence is greater than C2. So TIR or total internal reflection will take place. So using this concept you can draw the refracted or total internal reflected ray. Now question number 4 is, what is critical angle in relation to the phenomenon of total internal reflection? So this is simple theory question. Critical angle is what? This is the angle of incidence in denser medium for which angle of refraction becomes 90 degree. So this angle of incidence in the denser medium, as we know that this is the condition for TIR, that the ray must go from denser to rarer medium. So angle of incidence in the denser medium at which the angle of refraction becomes 90 degree is called critical angle. And second part of the question, mention two necessary conditions for total internal reflection. Two necessary conditions are, so these are two conditions for TIR. First condition is ray must go from or travel from denser to rarer medium, and second condition is the angle of incidence should be greater than critical angle. So these are the two conditions, simple theory question. Now last question is assertion reason question. Assertion is we need to check whether both the statements are correct or not. First let us check one by one. First assertion is question number 5. Assertion is a diamond of refractive index under root 6. So diamond refractive index is given as under root 6. This is a refractive index of the diamond. Is immersed in a liquid of refractive index under root 3. Liquid refractive index is given as root 3. If light travels from diamond to liquid, total internal reflection will take place when angle of incidence is 30 degree. So we have to check when the angle of incidence is 30 degree, then TIR would take place or not. So for that we need to find out the critical angle. So now here let us consider this is a diamond and this is a liquid. Now the ray of light is going from denser to rarer medium. Now let us find out the critical angle. For critical angle you can draw critical angle in the denser medium, that is in the diamond, and if this is a critical angle the ray would travel in this side, making angle of refraction 90 degree. So direct we can write here. So refractive index of diamond, so Snell's law you can use, or you can use the direct formula also. So here refractive index of the diamond into sine C is equal to refractive index of the liquid into sine 90. So this is the Snell's law. So sine C is what then? Sine C is refractive index of liquid or over refractive index of diamond. So sine C is refractive index of liquid is root 3 and diamond is root 6. So here what we would get, sine C is 1 by root 2. So angle of this critical angle would become 45 degree. But in assertion it is saying the angle of incidence is 30 degree. So we can say here that angle of incidence is less than critical angle. So here TIR will not take place. But here in the question it is saying total internal reflection will take place when the angle of incidence is 30 degree. But angle of incidence is not greater than critical angle, which is the main condition for TIR to take place. So here angle of incidence is less than critical angle. So TIR will not take place. So our assertion is wrong. And what about reason? In reason it is written as mu is equal to 1 over sine C, where mu is the refractive index of the diamond with respect to the liquid. Yes, this is clear. We have already derived this formula. Mu is 1 over sine C. And mu is the refractive index of the diamond with respect to liquid, mu d over mu L. That here also we have derived this. That 1 over sine C, sorry, this one mu is equal to 1 over sine C. You would get the same relation. So here reason is correct. So assertion is wrong and reason is correct. So you can mark the option as per the given instructions in the question. So this is all about 5 questions of today. Thank you.